Good afternoon, everyone, and thank you for joining us. This is Sarah Davison with VIAVI Solutions Marketing. I want to thank you for joining our call today on signal coverage mapping with the STI Field Test 7. I have just a few housekeeping notes to share with you. This webinar is being recorded and will be available for you in approximately 24 to 48 hours, and an email to all attendees with a link with the recorded version will be sent out. All lines are on mute, but we are monitoring the chat and will answer questions at the end of the webinar or reach out to you individually to ensure you get the answers you seek. And now I'd like to turn it over to our speaker today, Bill Nichols.
Thank you, Sarah. Good afternoon, ladies and gentlemen. Today we are going to be talking about outdoor signal mapping using the VIAVI 8800SX, the 3550R, or you could use the 3920. And we will be using the Field Test 7 from STI to do the mapping. I am Bill Nichols, Field Application Engineer out of Wichita, Kansas. Also joining us today is Mike Fortna, Application Engineer, and Dave Hansen, Application Engineer, both out of Wichita also. And they're here to answer your questions as we go through the details of outdoor signal mapping. When customers complain about two-way radio performance issues, such as losing RF signal range, poor audio quality, and spotty RF coverage, often the source of the problem is due to RF coverage issues and not actually the subscriber unit performance. Measuring the propagation of radio waves without the use of the proper radio test set configurations can be difficult and time-consuming. Environmental obstacles offer varying degrees of attenuation, multipath and Rayleigh fading, causing the radio frequency radiation patterns to be irregular and unpredictable. As a result, it's absolutely necessary to perform an RF site survey to fully understand the behavior of radio waves within the operating environment. Field Test 7 comes complete with the USB GPS receiver antenna, which you see down here in the picture. Setting in between my PC and the 8800. It also comes with the drivers for the 3920, the 3550, and the 8800 SX, all three of our radio test sets that we have for sale. And it also has the automated signal measurement and analysis capabilities and street map data for the entire US and Canada, and international maps can be imported easily. STI metadata can be used with the IB Wave, SoftWrite, EDX Engineering, RadioSoft, and Menem Planet for your predictive software needs. Just to start off, we're going to talk about the setting up the 8800, but what we're going to focus on our coverage testing today is kind of comparing and contrasting using frame sync and a 1011 pattern for BER measurements. And we'll find out more what frame sync is and a 1011 pattern here in a little bit. The connection between the service monitor and the STI software, the STI software resides on your PC, and you'll have an Ethernet connection from the service monitor to your laptop, and then you'll have the GPS receiver. It's got a USB connection that'll be on your PC. So the first thing that you want to do when you get the STI software is actually the setups. You already have the setups in your service monitors if you didn't know that. If you have one of these, the 3920, 8800, or the 3550, which I'm going to use today, those setups are actually in there in the setup files, but they also come along with the STI software so that you, for some reason, you might not have them, you can load them in. So the first thing that you do want to do on your service monitor, I'm going to use the 8800 as an example here, is you're going to go over to Utilities, and from there, you're going to go down to Store Recall, and you're going to go down to Store Recall. And once you get there, you're going to see sample setups and save recall. The rest of these are setups that I've made over time. But once you get in there, you do want to go into the sample setups directory. Once you're in the sample setups, you're going to see STI is one of the folders in there. We have a lot of setups in here, but STI is one that's resided in our service monitors for many years. And you'll just highlight that, and you'll hit the right path statement up here, and that'll open that up. And you'll have two setups in there. You'll have the STI analyzer if you want to do the sweep analysis. And for us today, we're going to use the digital setup, and this would be for any digital. If you want to do P25, DMR, NXDN, DPMR, ARIB 98, a couple of those are Asia Pacific applications that we don't use over here. But NXDN, DMR, P25 are certainly available for all of us here in the Western Hemisphere anyway. So you'll call that setup up, and this is what you'll have on the screen. Now, the STI software actually is going to set your frequency for you. It's going to set the DMOD type for you. It is also going to set the pattern. Now, you do want to make sure that when you recall the setup, as it should have the antenna port set. So all of this is done for you with the STI receive file. The one thing I would mention, just from experience, is this AGC setting. We're going to be out in the environment, and those power levels are going to be fluctuating quite a bit. And if you've got the AGC set to auto, it's going to sit there and try and negotiate with the incoming signal, and that signal is going to be, it's not going to be consistent at all. And so it's a good idea to set that AGC to a particular level. And for me, neg 90 works. So in my drive testing, my levels are, of course, neg 120 up to about neg 75 is about the best I see, at least in this drive test. And I was probably in my closest location, I don't know, I was probably maybe 10 miles or less from the tower, probably a little bit less than that from the tower. So about neg 74 was my highest reading. So I set it down to neg 90, and I got consistent readings, disregarding the fact that the power levels are going to be fluctuating as you drive through your area. Now, again, we're going to be comparing and contrasting using the 1011 pattern and frame sync during our demonstration today. Now, again, the STI software is going to set this for you. We'll see a receive file here in a little bit, and it'll show you. We'll show you how that's set in there if you want to, you want to set that to either setting. And I guess the last thing you want to make sure that you've got set up is you'll have that Ethernet connection from your PC to the service monitor, and that's going to be a static connection. I don't go into this right here, but that's all information that will be available for you if you decide to get this option. And people that have the service monitors, they know where those settings are. So you just set it to a static IP address, and just make sure it's compatible with the PC. You'll set the PC to a static IP address, and then you'll have communication between your PC and the service monitor. All right, so what's frame sync? On the control channel, you've got packet data units, and you get a packet data unit 1 and 2, among other things. But the first frame is frame sync, 48 bits, and that's what we're looking for. And this is in P25 is 9600 bits per second. So in 1 second, out of 9600 bits, we're going to pick out that 48 bits and determine what the bit error is on that. So you can probably expect, especially when you are doing a drive test, you've got multipathing and Raleigh fading, which we're going to talk about here in a minute too. That's going to impact the signal seen by the service monitor or hitting the antenna, if you will. And you're going to lose that frame sync, from time to time. But we're going to show you how you can become accustomed to what the variables are that you may see in that frame sync. So that's all we're looking for in frame sync. And the nice thing about this is you don't have to impact the system. You don't have to take the channel down. You've got an officer that drives in the garage and say, hey, at 3 o'clock in the morning over on 42nd Street and 59th, I don't have any signal over there. And so instead of taking the system down, you can go over there and do a little investigating. And you'll want to use this a little bit to get an idea of what frame sync looks like in your average environment. And then if you can, you determine that you've got a problem in an area, maybe you want to get use the channel analyzer or spectrum analyzer in the service monitor and take a look at the RF in the area. Maybe even go down into your 400 meg band and see if you don't have anything set in there that might be causing an image frequency up into your 800 meg band, if that happens to be what you're doing. As a matter of fact, that is our control channel is 852.1125 today. So I'll be talking about the 800 meg band today. So frame sync is a way to do a coverage test, quick coverage test, without impacting the system. Now, the 1011 pattern. The 1011 pattern, if you want to use this, then you have to have control of that channel that you are going to be monitoring. And so you're going to have to get with the people that own the system and say, hey, if you got a problem with this frequency, I've got to transmit a 1011 pattern on that to be able to do this coverage testing. And if you use frame sync and you say, I think we've really got a problem here, like worst case scenario in the situation that I'm going to show you, let's just say, for instance, that they were having trouble with the control channel and they wanted to, identify what the issue was. They could move to their alternate control channel and give you access to the main control channel for a period of time. You could put that 1011 pattern on there and you could do further analysis. But the reason the 1011 pattern is more robust, I guess, is a good way to put it, is that in that frame sync, we only had one little frame out there with those 48 bits, and we had to be able to capture that to be able to do that BER measurement. And with 1011 pattern, the way P25 is set up is that the information that is going across the air is interleaved throughout the frame. So what you're looking at here is a P25, it's a voice frame is what it is. So you have an LDU1 and LDU2 linked data units, and they just toggle back and forth. And as you're speaking, or you have a 1011 pattern on there, that's interleaved all the way through these 18 frames. So if you do lose one frame or two frames, you're still going to be able to get a decent BER measurement. Now the BER is going to go up because you are missing bits, but it's not going to be an either or, 0 or 100, because you've lost that only frame that you're monitoring. So the 1011 pattern, you get more robust readings doing that, but you do have to impact the system to do that. So now what we're going to do is I'm just going to go through real quickly and show you how easy it is to set up a project in STI, and then we will do our virtual drive test, because we live in a virtual world today, at least for the moment. And then we'll come back and we'll analyze our data. So the first thing you want to do is with your STI software is you're just going to go into the project setup. And once you're in there, then you will go to number 1 here, and you're going to give it a name, whatever you want to call it. Just give your project a name. We decided to call this project the STI webinar. And at that point, it'll ungray number 2, and then you're going to pick your drivers. So like I said, when you purchase the STI software, it comes along with the drivers for our service monitors. And for my particular drive test, I used the 3550. And so I would, at that point, I'd pick my driver, and then it'll ungray number 3, and then you can pick up the receive file. And I'm going to use the digital preset receive file up here. There's some other ones in the package too. Some of these I've put in here also, so you wouldn't see all of these, but you'd have the RSSI preset and you'd have a sweep preset with your STI package. So you pick the one that you want to use, and like I said, I'm going to use the 3550 for this drive test. Okay, once you have all that set, all you have to do at that point is hit the apply button, and you have created your project. Now, once you've created the project, you do want to edit your receive file that you've put into your project, and we'll talk about that right now. I'm going to show you what you can do with these receive files. So when you hit the edit receive, it's going to pop up on the window here, and I'm going to move down. Make sure I remember where I'm at on my time frame here. I'm going to move down and show you a little bit more about that. So this is that receive file, and our verbiage up here. There is a little caption here that says this capability can be used on one channel at a time, and the reason being is you can see these wait states in here. So just think if you wanted to do a DMR and an NXDN and a P25, 3 different frequencies, well, each time it shifts the frequency and the modulation format, then it's going to go up here and it's going to have a wait state of 4 seconds. And then you've got another wait state of 1 second before it starts making the measurements. So you got a good 5 seconds between switching from frequency and maybe even modulation. Not to say that you can't do it, but if you're going 60 miles an hour, you're gonna have some holes in your data when you get back. So we only do one channel at a time, and so the only thing, a couple of things that you might want to set depending on which system you're using. I'm in P25, so it's already set. The type is 0 for that, but DMR is number 1. And if you're doing NXDN, it's number 4 over here. So you can set that, and you can also see the ARIB T98 and also the DPMR. It also can be set as a system. Once that's done, the query for the meters is basically the same. The only other thing that you would have to change is the frequency down here. And this is the only thing I changed in here because it was already set to P25. So I didn't have to do anything other than go into my receive file and change my frequency. And then when you save it, you want to save it with another name besides the default preset name. It's already in your project, so it's not like you have to save it and then you have to go put it back in your project. It's in your project. You've just changed the name of your receive file in your project. Now, if you want to do multiple frequencies, you can do that. You would use the 3550 RSSI preset for that, and you can do multiple frequencies on that. And you can see down here that all we're doing is reading the RSSI, and we have a wait state of a half a second. So you can switch between these frequencies really fast because we're not having to decode any meter information. We're just reading the RSSI. So I just wanted to kind of clear up the receive files there, a couple of examples of those. Okay. All right. So let me find my place again here. There we go. So we've got our receive file set. And once we've done all that, we're going to go back to the main screen here. And at this point, we're ready to start our acquisition. So I'm already out in the truck. I've got my Ethernet connected. I've got my GPS hooked up on my PC, and my service monitor's turned on. I've got the preset called up on the service monitor, and I'm ready to go. So we're going to go ahead and hit the acquisition tab up there. It's going to put us into this screen right here. Now, in this window right here, It says no GPS reception because I'm basically in a Faraday cage here when I did this, set this presentation up. Now, you would be in your vehicle, and as soon as it comes in here and you go into acquisition, it's going to access that GPS receiver, and you would see your latitude and longitude show up over here. GPS reception would turn green, and your DOP, or your precision of accuracy, would turn green also. And at that point, you would go down and start the receiver, and it's going to communicate with the service monitor. It's handshaking across that Ethernet connection there, and once all of that's done, it'll come back and it'll say the receiver should be green. If it doesn't come back and say it's green, you've got an Ethernet issue there. Okay, so at this point, you're ready to start your drive test, but at this point, you can pull up either the map or the signal. I actually like watching the signal, and we'll talk about that here right now. What you would see if you actually had your latitude and longitude up here, GPS was green, DOP's green, receiver's green, you would see these two would be at low levels, and your RSSI is going to be up here around, neg 90, somewhere between neg 75 if you're close to the tower site, or you're not, obviously not setting underneath it, but if you're close, or it could be, like us, we're out here in the country, and I could end up, I'm way on the other side of town over here, so I'm going to see signals way down here. So the scale is for the RSSI. The BER and the BER and the modulation fidelity, they should be low. They'll be bouncing around because we're going to delve into this Raleigh fading and multipathing here in a second. You'll see why these bounce around, but they should be fairly low. If you're using frame sync, you are going to see this thing spike occasionally. That's just the nature of it. When we are checking for the BER measurement, and at that instant in time, that frame has been damaged, it probably is going to read. It'll probably spike on you. Excuse me. Okay, now the other reason that you're seeing what you're seeing here, which is kind of a chuckle, the latitude and longitude is set to 0 up here, and where lat and long is 0 is off the west coast of Africa. So my poor little 3550 here, it's trying as hard as it can to read that signal that's out in the water off the coast of Africa, and it's having a little trouble. So that's why our BER is so high, and why our mod fidelity is so high, and why we don't see RSSI. But anyway, when you're active, you're going to see RSSI and BER and mod fidelity should be moving around somewhere, I would say down below the -90 line in most cases. Now, the other thing that you have access to is the map, and you could pull that up. Now, on this particular map, I've already driven this path here. So all this red here is just the path that I've driven. And you're actually going to see this on Google Earth here. It's really makes all this very prominent, and you can do a lot of analysis on it. But anyway, you can watch your drive if you want to, but I think if you use this, you're probably going to have the signal called up. Now, having said that, you don't want to be in the truck, manipulating all this stuff as you're driving down the road. So especially the first time you do this, you probably ought to have somebody piloting the vehicle, and you can sit over here and work the instruments. Once you get comfortable with it, really the only thing you need to do occasionally is glance over and make sure that you still are receiving data over here. The 3550 is a touch screen, so be a little careful with it in the truck. You don't when things bouncing around, something bounces into the touch screen and activates. Maybe it shuts the receiver off. Those kind of things can happen. So as I'm driving, I generally will glance over occasionally and make sure that I'm still receiving data. So like I said, you've got a couple of different ways that you can look at that. Okay. Now, we're going to get into basically where we're at right here in our virtual drive test is we're in the truck and we're driving right now. And I want to prepare you for what you're going to see. A lot of you probably know this stuff if you work out in the field a lot, and some of you, if you're brand new to this, you probably would like to know a little bit about it. So one of the things that we run into is multipath propagation. In RF communication system, the signal can travel from transmitter to receiver over multiple reflective paths. The effect can cause fluctuations in the received signal's amplitude, phase, and angle of arrival. This gives rise to the terminology of multipath fading. And multipath fading refers to the signal's random fluctuation or fading due to multipath propagation. So in our picture over here, we have time theta, and this is the same signal coming off the same tower, but it's bounced off of something, and we're hitting the receiver at a different time. So that signal's out of phase, and that's going to impact your receiver. So that's multipath propagation. And that's just standing in one place and picking up signals as they bounce through the air. Now, the other thing that we contend with is Rayleigh fading. And antennas that are on moving vehicles receive many reflected and scattered waves. So those waves can come bouncing off of buildings, reflected off of items. And I was going to have some of these coming in from the back because we are running, these frequencies are moving at the speed of light, so they can catch your car, but I didn't do that. Anyway, the point is that many reflected and scattered waves are hitting that antenna as you're driving down the road. The received power seen by a moving antenna varies depending on the location of the antenna, and that doesn't mean whether the antenna is in the front or the back of the car. It means where it's at in space as the car's moving. Now, in our drive test, that wasn't a virtual drive test that I did. I actually did that over the weekend and yesterday, Monday, I guess. But this is the tower site. This is the Kansas Highway Patrol. This is where the Kansas Highway Patrol control channel is being transmitted from outside of town. So this is actually from the Google map itself. I actually went down after I did my drive test and located that. We'll see it on the map here in a second too. So, and that's outside of town. We've got some grain elevators over here, and I've actually, you'll see the plot here in a little bit. So there's some interesting things happening around those grain elevators and through town, as a matter of fact. So on we go. All right. My right bubble here. So we have done our drive test, and now you can do this in the field. I mean, you can do an acquisition out in the field, or when you're finished, you can come back to the shop and do this. But at this point, we've acquired our signal, and now we're going to go and configure this so that we can take that information and put it into Google Maps or use the statistical data for other reasons. So at this point, we're just going to hit data points. And once we hit data points, we'll be in this screen, and we're going to go to point and area. You could also do tile analysis, but for our example, we're going to do point and area. And it's going to bring this map up, and it's going to show you the path that you've driven. It's a little hard to see, but I did go all the way around the interstate here. Plus, I did all of this inside the western half of the city. Didn't do the other half. Now, once you've done that, you can pan zoom around and center this up. Mine was already centered okay. And after you've got it centered, you have it where you want to hit the rectangular statistics. And that'll give you the opportunity to take your mouse and draw a rectangle over the area that you want to compile that information. You don't have to do your entire drive. You can just do the small sections if you want to, depending on what you the output that you want. So I just drew a rectangle around the entire drive, and it'll be compiling that information. And once it's got the information compiled, it's going to ungray the graph data. And at that point, you can press graph data, and you'll see basically statistical analysis of your measurements. But what we want to do is we want to get this on Google Earth so we can go down and take a look at our results actually on the map itself. Okay, so at that point, I would have gone back into the main screen, and I would have gone and selected project again, then gone to general, and then export, and that's what we're at here for the export. And once you hit export, then it's just as simple as checking the Google Earth box, and then you can pick which measurement that you want to display. Now they're all going to be displayed. All three of them are going to be displayed, but it will whichever one you have highlighted will be the predominant one in your analysis. And so in this particular one, I decided to do bit error. Now before you make your KML file, you can go in and you can adjust your color contours for the map. And you have three of these. So you have one for RSSI, one for BER, and one for mod fidelity. And you can certainly color code these any way you want. This is kind of what I came up with because really BER's is good, clear up to 5 in the book. But by doing this quite a bit, I know that that bit error can be quite a bit higher, and these receivers and these radios can recover it. But 5% is that's our benchmark in the APCO standard, 5% bit error for transmitted BER. But this is, like I said, you can set these colors any way you want. Maybe your customer wants a certain set of colors, your boss does, maybe whatever colors you like. So you can set those up for all three of them. And then at that point, you're just going to go down and hit Create Google Earth KML, and you can save it to your PC, or it's going to ask if you want to go ahead and display that on Google Earth. Now, of course, you want to have that app ready to go on your PC, but if you do hit, if you have the app on there and you hit yes, then you'll see this on the display, and then you're going to get a little motion sick as it zooms into Earth, into your location, and it's going to end up looking, mine looked like this. So this was the first part of my drive test here. And the first part of the drive test, and this is the interstate. And this is an elevated highway, and it looks real, just a great looking plot that I've got here. I got a couple of anomalies here, but this looks just fantastic. By the way, my highway patrol tower is setting out here, so this is the point where I got my best coverage out here. And all I did was it just took the time to drive around what we call here in Kansas the bypass, and then this is actually I-35. So anybody that lives in the Midwest knows I-35 runs all the way from Texas to the North Pole, I think. No, not really. Anyway, so we can do a little bit of analysis on this real quick. You can zoom in using Google Earth. And because we didn't have many anomalies, I thought I'd get in and take a closer look at some of these. So we're gonna look at those a little bit closer here. Let's see, third bubble over. There we go. So on these bubbles, you can just tap on them as you go across, and it's going to give you the value. And like I said, whichever one you decide to display is going to be the prominent value up here, but you do have all three. Now you notice that I have a neg 93, the mod fidelity is 39, but my BER is 100. We're doing frame sync, and we lost that frame. And in our drive here, going 60 miles an hour, we lost it for a little bit. And like I said, you can go and do some analysis on that. So here's another one, levels the same, still getting 100. And it's because we've lost the frame. We're just not picking up that 48 bits out of that 9600. So you can do a 360 zoom around to take a look at your terrain. And I actually drove this twice to make sure this wasn't an anomaly, and it did occur 2 times. So it's kind of interesting that I get good, these green bubbles here, those are good mod fidelity, and BER is low. And then we've lost our frame sync out here and out here. So you can go down and you can look closer at your terrain. And it's always going to be terrestrial interference. It's either going to be natural or it's going to be man-made. And in this scenario right here, an officer driving this highway wouldn't have blinked an eye at this. This is frame sync. We lost 48 bits, and that's the reason that it went to 100. Now, if we had a whole path out here of 100%, I would probably want to take a closer look at this. But knowing how this works and the fact that it's just 48 bits that I lost at this particular time, and then a few seconds later I'm golden again, I know that that's a reflection off of something out here. We'll look at a couple more here, and then we'll look at what the 1011 pattern looks like. So this is just one of our other anomalies. Now I'm going to go right down to street level so you can see this. Now we're right on one of our red bubbles there, and this is something that you would probably call RF shadowing. This is a big metal building here. You can't see it. There's another metal building over here. And that truck was not in front of me. These are Google snapshots from who knows when, a year ago or so. But again, your interference is always going to be natural or man-made. And then we'll zoom back out. Just pointing this out one more time. The RSSI level is good, neg 85, that's great. Mod fidelity, even at 22, that's kind of typical when you do these drive tests. You'll see this fluctuate a little bit, but BER is 100%. So the point here is that RSSI signal strength does not tell you the whole story. And even using frame sync doesn't tell you the whole story either, but I'm not impacting my system. I'm just finding out if I can locate a problem area, and then I can go do further analysis on that. Now, we're going to look at the city just for a second, and then we'll move on to 1011. So on that elevated highway, everything looked great. Now we get into the city. Now this is Wichita, Kansas, and this path right here is right around the Arkansas River. If you live in Kansas, it's called the Arkansas River, but this is the Arkansas River, and we live in the Arkansas River Valley, created by a glacier many thousands of years ago. So we have a depression in this area here, and of course this is our river with the lowest point, at least in the city here. So it's wouldn't be surprising to see some anomalies down here in this depression of the city, and as opposed to this elevated highway, which is pretty much golden up here. Again, this is right at this is my strongest point out here. My site's right out here. My best level, neg 74, BER 0, mod fidelity 4. That's great. Can't get much better than that. And now you can go back and you can check out your terrain in the city. Earlier I showed you that tower, and off in the distance you could see this grain elevator. So this grain elevator setting over here. I don't know what the propagation of that antenna looks like. I did not do any analysis on that, but I just know that we have terrestrial events happening here that has probably caused a little bit of trouble in a couple of places. So again, you can always go down and look for trouble. One other item before I do the 1011 I thought was interesting was this out here on the highway where I had perfect coverage, had this one little anomaly here, and just out of curiosity, we wanted to know what the heck that was. Again, I lost my frame sync. That 140, my 48 bits, missed it. So I go down here and look.
It was like freaking out, like on my go-to audio.
Sarah? Anyway, that's what it sounded like when I went down to down to street level here. But anyway, you saw this overhang here. So again, a terrestrial event, man-made, probably causing a little reflection off that when we got that 100% BER. So now let's see what happens when we can take the channel down and control it, put that 1011 pattern on that channel. Now I'm going to quickly move to the state of Oregon. So hang on. So we are now in Oregon. We don't have any oceanfront property here in Kansas. But the reason I did this is because Carl did this survey out there and actually using the 8800 on this. Could have used the 3550, but I had the 8800, and they actually had the 1011 pattern on the channel. Now his bubbles are different colors. He used a different color scheme, but you can see very consistent all the way through here. And this is what you would see if you're using a 1011 pattern. You're going to have more integrity, obviously, on the BER measurement, and your mod fidelity is going to it won't bounce quite as much either. So we'll look at a couple of these, and so we got neg 84, but still perfect BER, and the reason is because that 1011 pattern now is interleaved through the entire super frame, 360 millisecond super frame, and even if we lost a couple, that BER's, we'll see the BER jump up, but you're not going to see 100%. Unless you've lost everything. So now here we're out here and we're getting blue indications. So he's got his color levels set to indicate that we've got some signal issues out here. And the level is neg 109. That's not particularly bad for a radio, but we've lost some frames now. We've got some problems reading those frames, and you can see the mod fidelities also come up kind of consistently with that BER as we move through. And but by the way, I give classes on this stuff. Mod fidelity is the jitter on the C4 FM. That's what they're monitoring, is the jitter on that, and that has to be less than 5% too. But it's a different measurement. And of course, if you need to, you can always use Google Maps and go right down to street level and take a look around, see if you can determine what your anomaly is. And so you can do all of this before you, especially with the frame sync, you can do all of that without even impacting the system whatsoever, and get kind of an idea where you might be seeing some bad spots. Now, on the frame sync, you did see 100%, so you'd have to get used to what this frame sync, how it reacts in the area that you happen to be in. And once you work with it a little bit, you'll kind of get an idea of how it behaves. And if you get into a bad area, you can say, well, this looks a little bit different than what I'm used to seeing. Let's take that signal down and put the 1011 pattern on it. So you'll have to go in and talk to the powers that be and so that you can get control of that channel. All right, that is comparing and contrasting the 1011 pattern, doing a drive test using the FT7 STI mapping software. Now, a couple of things that I hadn't talked about as we went through this, just due to time. Here's your color contour map that you also can create in STI. And this is your statistical analysis that I could have done after I plotted my my area. And so you could also get this type of information here. And then this would be the RSSI, where we've got multiple frequencies out here that we're sweeping through at half a second each. The other thing that I didn't mention was you can set waypoints on your map. So you could put all your tower sites out there. You could also identify all your cellular sites out there, and you could identify those too. So you can readily find those. They're easy to find. I found them pretty easy, but you can also make waypoints out of them so that you know they're there. So that in 45 minutes, like I said, there's a lot of capability in the STI software using the VIAVI 8800, 3550, or 3920. So of course, if you want more information about it, if you have any questions, we're going to open up the lines for questions now. And if you need to get a hold of us, you can contact the webinar folks here at rts.webinars@viavisolutions.com. And if you have any customer service related questions, here's the number here, 800-835-2350. And there is a 1-minute survey after we get through here. So let's go ahead and open the phone lines up there. Dave, Mike, do we have any questions out there?
Thanks, Bill. They're actually, we've got a couple questions here. They actually are very similar in nature, I guess. Well, I guess there's one question repeated, sorry. The question was, how does this work with the trunked system? And more specifically, if you're monitoring a trunk system, obviously, when we're doing this drive test, we're not going to be handing off to a voice channel or whatever. So the way that Field Test 7 works with a trunk system is that, of course, you can set up the system to transmit your 1011 or an O.153 or V.52 pattern and monitor that. But the other thing you can do is using the frame sync pattern, we can monitor the control channel, and which of course that's going to be there all the time, and we don't have to actually interact with the system at all. So
yep, and that's what we did today. That was actually the control channel for the Kansas Highway Patrol. And I didn't have to call them or bother them, and they didn't call me. So everything was good.
Let's see here. Just real quick, the email address there for the contact is rts.webinar. There's no S at the end of that.
Oh, really? We need to fix that, huh?
Yeah, okay. So if you send it to the rts.webinars, it's going to bounce.
Wow, that's been in all mine. I gotta fix that. Sorry about that.
So let's see here. Yeah, it looks like we're getting a few more questions that are coming in now. Let's see here. Sorry, Jay. Yeah, at least you do know now. Let's see here. And Bill, I guess so. See if you want to answer a couple of these.
You're not going to ask me what DOP is, are you?
You want me to?
Go ahead. No. What's the question?
Okay, so do we have the ability to combine maps? So if you say do a drive test from day one, and then the next day you do a drive test over another area to combine those two.
Oh, absolutely. That is what I did. I did the when you saw me on the interstate out there that looks so good. That was done. That was my Sunday afternoon drive, and then on Monday I went down into the city and did the city drive. And so when you have a project, all you have to do is start the receiver, and it's going to start right where it left off as far as accumulating data, and you don't have to go back to the point where you stopped either. You can start at any point.
Wonderful. Leo, is there a realistic way to drive test a conventional P25 system? I guess maybe I'm not entirely sure what you mean by a realistic way to drive test. What Bill did in his
it was realistic. It just looks virtual at this point, right?
It was very real. Yeah, exactly. So I mean, that was a real drive test. As far as a conventional P25 system, maybe you're talking about, yeah, no control channel there. In other words, it's not transmitting continuously. In that case, I think you would need to be able to put one channel into a test mode or maintenance mode to where you could transmit a specific pattern, and then you can monitor that pattern.
Yep.
Can you inverse the color code? Taro was asking, can you inverse the color code where red is bad, make that red is good, and green is good, make that green is bad?
Absolutely. You can you do with those colors what you want. You can invert well, I do believe that the bottom of your bottom measurement does have to be the least, but you can switch those colors around to any color you like.
Right, and you know, more to that point, if you recall, in Bill's drive test, he had the colors set to red and green. When he pulled up the Oregonian drive test, that one used colors blue and yellow, and I presume shades of those in between. So, let's see here. And well, Jay says that the rts.webinar at VIAVI-solutions.com also failed. Give me a second, Jay. I'm gonna try that out myself here, and see if I also get a bounce. Hopefully, hopefully there's not a technical problem. Let's see here. It looks like it went through for me, so I'm not sure. I'm not sure why that's failing for you. What we'll do, I will. We have your contact information, Jay, so I'll send you an email directly if you do have questions in the future. I know you mentioned that you forgot what the question was you were wanting to ask before. If you could think of that question or other questions, then you can feel free to email me directly, and I'll be happy to send that to you. Bill, do you did your slide with the our contact information, our personal contact information, was that in there?
It's not on this slide deck.
Not on this one. Okay. Anyway, like I said, Jay, I'll reach out to you so that you have a point of contact. Well, I know we're starting to get close to the 1 hour mark, so I know there's a couple of other questions that have been submitted. We'll get back to you offline and answer those questions. If you do have questions, of course, there is the 800 number there that Bill has on the slide. So if for some reason that email address, yeah, that does work.
So, does work.
If for some reason we're not able to, you're not able to get through to us via email, please feel free to call that 800 number and let the operator there know that you have questions about using the Field Test 7 software package or any other VIAVI Solutions radio test set question that you might have, and they'll be happy to direct you to either one of us or one of our technical support group. And yeah, so thank you everybody for joining, and I think I know Sarah was having some technical difficulties on her end as well, so like I said, we'll get back to everybody on the questions that we didn't get to on the webinar, and thank you everybody for joining, and have a good day.
Have a great day.